Today we're talking about a tuner's best tool, wideband oxygen sensors. Stick around. What is going on, everybody? Welcome back to the garage, and today we are going to talk about wideband oxygen sensors. Not necessarily specific brands of gauges and things like that, but we're going to talk about the different types of oxygen sensors and placement and a couple other tips that are going to make your tuning life a lot easier. And while I'm at it, talking about making your tuning life a lot easier, go down to the description below. Check out the links there, specifically right now the one for HP Academy. We've got a link down there with a custom coupon code from Goat Rope Garage. Save yourself a little bit of money on some of their courses. Go browse. It's free. They have free lessons out there that can give you an idea of whether or not you want to check them out. So highly suggest you hit them up. I'm still working on the diesel tuning course. Been learning a lot over there. And a big shout out to HP Academy for helping us out here. But let's go ahead and jump over to the table and take a look at what we're talking about. Okay, first things first. Let's get into it. There's basically three major types of wideband oxygen sensors out there. Two of them by Bosch and one by NTK. We're not going to be covering the one by NTK because honestly, if you need an NTK, you already know about widebands and this information is really not for you. They're really great if you're running straight methanol, things like that, because of the wide range that they can read in. Now, when it comes down to Bosch, we've got two styles. We have the 4.2, which is the older generation sensor, but you can still get gauges out there and standalone ECUs that use a 4.2. The quickest way to distinguish it is it has a square connector on the end, whereas the 4.9, which is the newer generation, has kind of this D-shaped connector that's flat on one side, round on the other. These are not interchangeable. The controllers for the wideband work differently between the 4.9 and the 4.2, so you can't repin things out and expect them to work one way or the other. So if you're running something like a Holley HP, which uses a 4.2 sensor on it, unless it has the support for a 4.9 driver, you can't swap over. Then whenever you swap over, you do have to make sure that the pins are the same because the pinouts do not line up one for one. What might be on pin A on here or pin 1 is not going to be the same for the 4.2. Now, is there any benefits of the 4.9 over the 4.2? Not really. I'll be honest with you. They say that it's a little bit more resilient to shock. And by shock, I'm talking about temperature fluctuations, things like that. And that's important whenever we're talking about if the car's been sitting for a while, it has some condensation in the exhaust, you fire the car up, there's a chance that you can shock the sensor and actually cause it to fail. Other than that, something to keep in mind is this section cannot be rewired. There is actually a resistor in here that is part of the calibration circuit that it needs to see. If you change anything in here, there's a good chance it's not going to work after you change that. And that goes vice versa for the 4.2 and the 4.9. So keep that in mind whenever you buy one of these, that it doesn't really matter. You just can't change this section. Now, beyond here, whenever you're going back, yeah, you can shorten that up, repin it, etc. But this section needs to stay as is. Now, when it comes to official, Bosch versus some of the Chinese knockoffs, I've ran the Chinese knockoffs without any issues other than they tend to die a little bit quicker. So keep that in mind. And then a lot of the different ones, in fact, this one is a 4.9 for an AEM setup. A lot of these will say that only the AEM ones will work with it. That's not true either. So if you have a Holley and they're trying to tell you that you have to have the Holley sensor, no, you don't. You can go out there, try some of the cheaper ones, and then also look, because some of these sensors were a manufacturer OE sensor. You can pick some of these up at your local auto parts store if you know which part numbers to look for. Keep that in mind. They are going to be expensive though. You're looking at probably $100 to $150 for a wideband sensor. You can generally pick one of these up on Amazon for about $30. I like to keep a few spares around. That way if one fails, I can quickly swap it out and get back on the road to tuning. You can, on most of these setups, do a free air calibration. In that, you need to take it out of the exhaust to do it. It's not something that you can leave in the exhaust. Take it out of the exhaust. Basically just let it set in free air and let the controller go through its processes to make sure that everything works right. But what you're going to see on the majority of all controllers out there nowadays is that they're going to be a 4.2 or a 4.9. So what I would suggest is find the controller or gauge that has the features that you're looking for. I like the AEMs because they have the serial out. The serial out provides better data than the analog out does, and that's why I end up running like the 300300s on about everything. I'm doing this one a little bit different. I've got the inline unit from AEM because I didn't want to gauge, but it still has serial, analog, and CAN bus out, so that'll be very interesting. But now let's talk about mounting your wideband. Okay, I've got two setups here. I've got a factory catted section and an off-road test pipe section, and down here is where we're going to connect into the headers on this particular platform. And so all 4 ports from the exhaust headers are coming in right here, and you can see the factory location for the front sensor has very close in reference to where that is. And so whenever we come in and add a wideband, we're going to want to try and keep it within the same range. Now on a test pipe, we have a little bit more room, and I've gone ahead and added one here in between the front and rear. On this one, I would probably pull the heat shield and try to find somewhere around the factory front to get one in, possibly over here, but that brings up a good point. Whenever you do this, make sure you crawl underneath the car before you take all this stuff up and check for clearance, because you have to have this much room sticking out in order to get it to work. One other thing to keep in mind, if you're going from a stock setup to a test pipe or something like that, the rear O2s need to be disabled in the DTC list before you remove this. If you remove this and then go disable them, the check will already have ran and you will get a permanent DTC failure. Just look for sensor 2 on bank 1 and bank 2 DTCs for that. Now, diving into our wideband mounting here, as I said, our idea is that we want to keep this relatively close. The further back that we are on these pipes will cause delay in the reading. So what we're reading here in AFR, we're getting that reading fairly quick. If you're using a tailpipe sniffer, or you're further back in maybe where a Y pipe joins the 2 into 1, then you're going to have some delay on the reading. Whenever you go into transient, that can cause some issues as far as tuning. So the idea is keep this as close as possible. If you're running a turbo setup, I would generally suggest running it right after the turbo. If you run it before the turbo, there's a chance that it could get hot and you can go through these sensors a lot quicker. So keep that in mind, but you still want to keep it in as close proximity to where the reading can be taken on the exhaust path. Now, the other big thing, welding. I've gone ahead and added this bung in here, and I don't know if you can tell, but there's a spot here where I had to go over and add a second bead. This was a pretty good weld from the get-go, but anything that looks like it could be a pinhole or maybe a spot where the 2 weld beads did not come together and melt properly, I'm going to go back and do another pass over, because one of the biggest problems that you're going to have when adding a bung is getting a small air leak. And I can tell you that it can be the smallest, most minute air leak on the face of the planet, but it is going to skew your data and cause you to chase your tail. So when in doubt, if you think there might be a spot whenever you're having a bung added on, go ahead and put an extra bead on there to keep yourself safe. Same ordeal, if you're taking your exhaust somewhere else to have a bung installed, inspect what they did, make sure that it was a clean weld all the way around and there's no spots for air to penetrate the weld and cause false readings. And this is an example of the wideband bung or O2 bung that I like to install. You can see that there's a step on here. You can drill this thing out big enough where it sits down in the pipe, and that step gives you a little bit more meat and a little bit more shielding of the possibility of having a small pinhole leak around it. If you think you have a pinhole leak, one easy way to test, swap your O2 sensors. You can always just go ahead and swap these around and see if your readings change whenever you move into a factory weld. Now, last but not least, what if you don't want to put a bung in? Well, whenever we tune, we're disabling these front O2 sensors, and since we're disabling these, you can go ahead and just pull a front O2 sensor, install your wideband in the front spot, go through your tuning process whenever you're done with it, and you want to go back into closed loop, take your wideband out, and put your narrowband back in. And one other thing, a quick thing to look at to tell whether or not your car already has factory widebands, count the wires. Anything with less than 5 wires is going to be considered a narrowband. Anything with 5 wires or more is generally going to be a wideband. And so you can hook your scanner up, pull in your data, and see if it is reading a true lambda value versus just a 0 to 1 volt, which is what narrow bands read. Wide bands read 1 to 5. That's why they're called wide. They've got 5 times the resolution. And so that's why we tune with wide bands and not narrow bands, because narrow bands can't read anything outside of the range of stoic. The whole idea on a narrow band is whenever it's running stoic, the voltage is switching around 0.45 volts all the time. And if it sees it hunting right around that 0.45, it knows that everything's dialed in good. Whereas with our wide bands, we can see the actual air to fuel ratio, and it allows us to make the proper adjustments to our tune so we're making the most power and we're staying safe. Okay, that's it for the rundown on wideband sensors, which kind of sensors there are, where to mount them to get the most effective use out of them. Just a quick refresher on that answers a bunch of questions that people are always asking. And so if you have any additional questions, go ahead and hit up the comments down below. Make sure and check out the description, check out the Patreon if you're looking for tune assistance, all that fun stuff. Don't miss the live show on Thursday nights. You listen, I'm going to get back to it. You know the drill. Thanks for stopping by the garage. And remember, ABT, always be tuning.